Implicit differentiation, again, is used when we want to differentiate a function that is only defined implicitly. So for example here, let's see I have a big function f of x, y and z, but now z depends on x and y implicitly. So then how do I find dz by dx? And for this we basically have two methods. One is kind of the good old calculus 1 method, and 2 is the method which we learned in this course. So the first method is just to differentiate the whole thing. Differentiate it by x, use the chain rule, and then solve for dz by dx. The new method which we learned here now is to write dz by dx as partial derivatives of the big F function. So dz by dx equals minus fx divided by fz, where the index again is used to indicate partial derivatives. So here's an example where I like to try both of these methods. So the function sine of xy plus pi y squared minus x is 0. Find dy by dx. In method 1, we just write an implicit function, big F of xy is 0, and then use the chain rule and differentiate by x. Okay, so then this big F would be sine xy plus pi y squared minus x, but now always understanding that y is a function of x. So if I differentiate this, what do I get? Differentiating sine gives a cosine, but now the inner derivative is a derivative of the product xy, where y is a function of x. So this is a product rule for the inner derivative. Differentiating x, I get a y. Keeping the x, differentiating y, I get the y prime. And then the pi term gives me a 2 pi y and an inner derivative y prime. And then the x term gives me a minus 1. There's no y in that term. And all this together is equal to 0, because if I differentiate 0, I get 0. Now let's isolate the y prime term. So then we get y prime times x cos of xy, and then plus 2 pi y from there, and then equals, move the 1 to the other side, and the other cosine term, cosine xy times y. Yeah, now I think I have all the terms. I can solve it for y prime. So then y prime would be 1 minus y cosine xy divided by x cosine xy plus 2 pi y. That's the result from the implicit differentiation. Now let's try the other method, where we use the formula. In this case, dy by dx would be equal to minus fx over fy. Actually, here's a funny way to remember this. Just think crosswise. Okay, here y is on top, so fy goes to the bottom. And there x on the bottom, so fx goes on the top. So crosswise, think crosswise. And I cross this out again. So we need, first of all, we need to find f, which is sine xy plus pi y squared minus x. And then we need the partial derivatives. So partial x derivative of f would be cosine xy, and the inner derivative now is just a factor y. And then the y term has no x, and the x term there gives a minus 1. The partial y derivative again gets the cosine xy, but now y is a variable, so the inner derivative is an x. And then this is 2 pi y, and that's that. And so using the formula, we get dy by dx is minus fx over fy. Subbing it in, this is minus cosine xy times y minus 1 divided by cosine of xy x plus 2 pi y. And we get another result. Now, let's compare with the previous one. Maybe I just copy and paste it over. So this was the previous result. Okay, the minus sign takes care of this. So yeah, same as before. It also looks a little bit easier, right? Using the formula, you just need to write down those two partial derivatives of big F. This was not very hard. Let's do this for a more involved example here. Here we have a function of three variables, x, y, and z, and it implicitly defines a surface z of x and y. And we would like to know dz by dx and dz by dy. So what are the formulas? The formulas is then dz by dx. And now I thought you should think crosswise. So the bottom is x, so the top will be fx, and the top is z, so the bottom will be fz. And then we have dz by dy. Again, think crosswise, so then fy goes on top and fz goes on the bottom. Meaning, we just need to compute the partial derivatives of big F. So the x derivative, for the first term we keep yz, and then we differentiate the minus cos, which is minus sign plus sign of x plus y plus z, and then the inner derivative of x plus y plus z with respect to x is just 1. Similar for fy, if we differentiate by y, we get xz in the first term, and we actually get the same sign term of x plus y plus z. Fz would then be xy plus sine x plus y plus z. Okay? And then you can easily build those two ratios, which I indicated there. So then dz by dx would be minus, taking the x derivative of big F, yz plus sine x plus y plus z, divided by the z derivative, x, y plus sine x plus y plus z. And then the other one, dz by dy, would be minus the partial y derivative divided by xy plus sine x plus y plus z. Yeah, so this method turns out to be rather easy. Memorize these two formulas, and then you only have to do simple partial derivatives to find an implicit derivative for this surface.